Hey guys, I'm going to be showing you today about how to deal with polyatomic ions in formula writing. The thing about polyatomic ions that separates them from monoatomic is, as it would imply, you're dealing with more than one atom, okay, that has an overall charge. And the idea behind these is that they are a fixed group of atoms, meaning that they occur in fixed ratios. So you'll never see subscripts change, and I'll show you that in a moment. Fixed group of atoms with an overall charge. Now, most of them are anions. So most of them you'll see are anions, but some do show up as cations. The most common here is ammonium. Ammonium is one nitrogen, okay, four hydrogens with an overall positive charge. Hydroxide shows up a good many times. That's an oxygen and a hydrogen with an overall negative charge. Okay. Sulfate is SO4 with a -2 charge. And phosphate is PO4 with a -3 charge. Okay. Now, these charges and all, those will be able to be found on your reference sheet that I put in the classroom, along with the names. So the names will always stay with the ions. Now, only a little bit tricky to deal with these is formulas writing, but I'm going to show you a couple examples here and give you some practice. So formula writing with polyatomics, and I have two examples here we'll look at. Okay, the idea remains the same, is that once you see the pairings, okay, in this one, sodium and cyanide, and yeah, that is the cyanide that's poisonous, okay, you're going to just go ahead, find the symbols, find their charges. If they're just elements, use the typical way of figuring out those charges. Some of them do show up on your reference sheet, but again, you can use your periodic table reference. Sodium, we've seen before, is Na with a positive charge. Now, cyanide is a polyatomic. Now, don't fret if you're one of those people that looks at a polyatomic and tries to find it on the periodic table. This happens a good many times. Okay, but look for things like ites, ates. If it ends in ITE or ATE, you're definitely dealing with a polyatomic. Cyanide's one of those that seems like it could be, like chloride, which we know to be chlorine. Okay, but cyanide is a polyatomic ion that's carbon and nitrogen with a -1 charge. Okay, so once you have that, you're all set. Crossover method remains the same, and now this one's going to be a little bit straightforward. Okay, switch, crisscross, and then you're going to write the symbols next to each other. Okay, so you end up with NaCN. Now remember again, when you're writing formulas, to keep things uppercase if they're originally uppercase and lowercase if they're originally lowercase. So that is the formula for sodium cyanide. Okay, you definitely want to ingest that. It would kill you. Our next one, and this is a unique case that you're going to also see a Roman numeral show up. We're dealing with iron 2 and nitrate. Iron 2, of course, is the +2 form of iron. Okay, the +2 form of iron, so you're going to use Fe +2. Now, nitrate, okay, is a polyatomic ion. ATEs and ITEs also going to have oxygens in them. So nitrate, and you guys can find this on your sheet, is NO3 with an overall -1 charge, or a negative sign. Okay. Now here's something to keep in mind. Remember I said that these are a fixed group of atoms. Okay. So when you are writing formulas, okay, when you combine these, you're going to be a little bit more careful here. Let me show you why. Okay. When you do the crossover method, if your polyatomic gets a number greater than 1, okay, you've got to make sure you put parentheses around it, like so. Okay. So be careful with that. You want to put the polyatomic in parentheses, then the subscript. And we'll practice this as we go on.